Hi, welcome to ECC4707 Computer and Network Security video presentation for our mini project Race Condition Vulnerability. This will be our title and we are from group M.5. My name is Chong Jun Wai, my track number 188379, and my partners is Noor Afifa binti Abu Hassan 187931, and our lecturers for this course is Dr. Fazirul Hisham. Okay, so I will move on to the introduction. What is race condition? Race conditions were known as a serialization flaws where multiple processes access and manipulate the same data concurrently. From this event, we were able to exploit the delay between time to check and time to use. So let's say if a privileged program has a race condition, the attackers may be able to affect the outputs of a privileged program by putting influence on the uncontrollable events, which shows that there is a vulnerability exists between these race conditions. So in our mini project, we will demonstrate with users request to access file. How are we going to exploit race condition on users request to access a privileged file by a non-root users? Okay, so now we move to a task explanations. So in our mini project, we have 4 tasks. The first 2 tasks is actually exploiting the vulnerabilities, and the remaining 2 tasks will be the countermeasures applied in order to prevent this vulnerability. First of all, task 1 will be choosing our target. Second will be launching the race condition attack. So on these 2 tasks, we will explain how we are able to choosing our target will be etc password file, and how are we going to launch this attack to cause vulnerability by accessing a root privilege, to accessing a user from a non-root privilege to privilege without keying in or without typing or keying any password. Okay, so now we'll explain more in task 1. Choosing our target. First, our target is to verify the magic word. This is the user ID. This is the hash value for the empty password. This is the 0. Okay, so these are the steps required to complete the task. First of all, we will log in as a root privilege users as we have preset earlier. And then we will check the access right of etc password file. And then from here we can see that these files were able only to be written by a root privilege users and only read by a normal users. So a normal users unable to write this file. Okay, so in order to write this file, we will use this command nano, then a /etc/psswd, and then we will insert the entry of this entry to this etc password file, and then after we have write from this file, then we will exit to a normal users, and from the results we can see that when we just access as a root privilege by typing su stands for accessing root with the user ID of test, which is this one, the same thing, this is test, and without keying or typing any password, we just click enter, we were able to access root privilege as a super user. Okay, now we will demonstrate our task 1 video on how is this gonna be conducted. So now we will talk about task 2, launching the race condition attack. The target is to exploit the race condition vulnerability in the vulnerable set UID program, which is VLP.C, in order to gain root privilege as a normal user with symbolic link method. And our target file will be the same also, /etc/pssswd file. So what is symbolic link? It's also known as a soft link, which it is a special kind of file that points to another file. It's almost like a shortcut in simple word. Okay, so now we'll talk about the flow of attack, like the steps required to be conducted. First, we'll require to create a regular file X, we name it as XYZ inside a TMP directory, which able to pass the access check actually. From there, we change TMP to a symbolic link pointing to etc PSSSW file, which unable to access by a normal users. Then we'll open the check from the EID, which is root, and also open password file for write. Okay, so this will be the flow of attack, and there is also an issue, is actually the chances of attack, because as there's programs run billion of instruction per second, the window between the time to check and time to use TOC/TOU to last for a very short period of time, so making it impossible to change to a symbolic link. If the change is too early, the access will fail. If the change is a little late, the program will finish using the file. So this is the time window we have been mentioning, which is between the access and the open. So from this window itself, we need to make tmpx point to etc password file. So instead of pointing to a dummy file we have created, we need to point to this file which only able to access by root privilege, and we were trying to make changes as a normal users to exploit this vulnerability, of course. Okay, to understand more on this attack, so we'll have programs to run concurrently. One is the attack program, one is the vulnerable program, which is vulp.c, that consists of vulnerability, and attack is we'll keep making changes between the symlink of tmpx to point the file owned by us, and also the pointing to etc PSWD. So we'll make a program which is continuously loop between these two processes. And the vulnerable program itself, we'll be able to check the permission and check is there any modification at etc PSWD file. If yes, if it's been modified, then we have successfully exploit the race condition vulnerability. Okay, so we move to next. These are the initial setup. First of all, we were required to disable this built-in protection against vulnerability, against the race conditions attack. These protections were actually built in by Ubuntu, which restrict the program to follow symbolic link directory. Okay, so this is our vulnerability program, vulp.c. So as we have mentioned just now from the diagram itself, this is the place where vulnerability, where the time window gonna be occur. So we are trying to attack between the access and also the open time, the time window between access and also open. So this vulp.c is able to write to a file in TMP directory were writable. Means as a normal users, you were able to write this file and also execute this file. So as the super users root can write to any file, the program ensures the real users has the permission to write to the target file. So this access, which is system call checks if the real user ID has write access to TMP XYZ. So TMP XYZ here, check is as that has the right access. Okay, so because TMP XYZ is just a symbolic link which is pointing to etc PSSSWD, which is which able need to access root privilege. So we were required to point to a dummy before going to the target file. So to exploit this, we need to bypass this. We need to put a dummy file which is able to read and write by a normal user as well. So after check, the file opens for writing, which is here, fopen, and then write will be here. So the fopen system will call to open the file and append the input. So we are required to exploit the time window between access and also open. Okay, so ABC, as we mentioned, is a dummy file that can be well readable. Everyone can write this for normal users or privileged users. So we'll go next. This is the two shell script file we are going to use, which the programs we're going to use to run a parallel attacks. One is called victim.sh and one is called attacker.sh. So we'll discuss more on victim.sh first, what it is. So from here, this thing called check file, which is actually print out the etc PSSWD timestamp to check. So there's the old check and a new check here. So we'll do a print stamp. So this will be the entry required to be and to add it into the etc PSSW file as a normal users here. So this will run the vulnerability program via lp.c entry via PSSWD file will be the entry of this, and we will do check. So let's say if it's not occur, so it will continue loop because O equals to new. So if it's still the same, then they'll keep looping until there is a modification done. Then will break the loop and will display notification of stop. The PSSW file has been changed. Okay, so this is victim.sh. It's actually the vulnerability file, vulnerability program, and attacker, which is the attack file we're talking about. So how is this causing it to be attacked? Where we will concurrently have a loop run in infinite loop we call. So we'll create a symlink to a dummy file ABC, and at the same time we will change the symlink to etc PSSWD, which from here we're able to create the short windows, making it to exploit the vulnerability itself. So you'll keep run in infinite loop from here. Okay, so this will be the results as shown. We will run both attack in parallel, and then run both attack and vulnerable program to start the race. We call it's like run in parallel. So as a result, you can see where there's no permission, it means that we are unable to access due to access right issues, as a normal user will unable to access to etc PSWD until at it changes at 2542 times, where this notification pop up say stop, the password PSSW file has been changed, means there is a modification has been done at this file. So to prove this, we have this before we launch this attack and after we launch this attack. The timestamp here you can see there is difference in the time. So same date, June 25th, and the timestamp is this is 14:37, which is 2 o'clock 27, and this is 3 o'clock 36 minutes. So you can see there is a changes in time, which means that the file has been modified before, and the access right will still remain the same. It's only able to write by a root privileged users. So we will do tests. So we will have the same thing. We just type the command su test, which means that log in as root privilege with test as the user ID. So as the results we have been expecting, we're able to access to root privilege. As you see, there is different in the symbol here. Root also is written here, where we're able to access root privilege without the need of password. Okay, so now we'll move to a video demonstration on how is this gonna work.
Hello, hi, Assalamualaikum. My name is Nur Afifa and I will be presenting task 3 countermeasure applying the principle of least privilege. So the target of this task is to protect against this attack. A set UID system call is used to manage the permission in our Valve scripts. So it will set its permission to that of the user who created it, which is the owner, instead of setting it to the user who launched it. It allows a user to execute that file of or program with the permission of the owner. This is primarily used to promote the privileges of the current user. So if a file is set UID and it's owned by the owner, by the user root, then a user that has the ability to execute that program will do so as the user root instead of themselves. So let's move on to the steps. So first thing first is we open the valve.c object file and we add setuid system call into between the access and open. And this is to fix the vulnerability of the time window of time to check to time to use between the system calls. When the fopen is completed, the root privilege of the valve.c object file is enabled back. So this temporarily disable the root privilege, and then compile using GNU compiler collector GCC. And this command here, gcc dash or valve.c command compile the program, which then create an executable file valve from the object file valve.c. And sudo chown root valve command will change the owner user to root for valve executable file. And this command sudo chmod 4755 valve give permission of valve executable file so that the owner, which is or the user, you, can read, can write, and can execute. The group G can read, cannot write, and can execute. And also or the others can read, cannot write, and can execute. Continue the chmod u plus x attacker.sh and chmod u plus x victim.sh command grant the owner or the u to have execute permission by changing mode of the file and add the permission. So this is the result of this task. As we can see here, the victim.sh it said that the segmentation fault core dumped, and in the attacker.sh although making 16,094 times changes of the directory between dummy file and the protected file, the victim.sh, as we can see here, script shows error message, which is segmentation fault core dumped, means the program trying to read or write in an illegal in-memory location. We were not able to successfully exploit rest condition vulnerability when setuid system is applied. So the summary of this task is that some attack is done, but unfortunately this time it fails. This is probably because once we are through the checks, the effective user ID, which is the asset UID, is made sure as 1000, like this, or also known as the non-root user once through the checks. Then after finish with the unsafe operation, the permission is reset back to the root privilege, the set UID 0. In this way, the section of code that are unsafe can be managed but still allow root users to access in the privilege area. of the script, which makes it much safer than simply doing file checks. So now let's see the demo video. Okay, now let's continue to task 4, which is Ubuntu's built-in scheme. So the target of this task is to exploit race condition vulnerability similar as task 2, but enabling built-in protection against race condition attacks, the symlinks. So first thing first, the symlink protection needs to be enabled so that the links created by one account cannot be followed to a file or directory owned by a different account. This symlink protection works by restricting to who can follow a symlink. So the how we will enable this protection, I will explain later. So first thing first, we open the valve.c object file like in task 2 and compile the program using GCC compiler, and the GCC -0 valve c command compile the program, which then create an executable file from the valve.c object file. And this sudo chown root valve and sudo chmod sudo chown root valve command changes on a user to root user for a valve executable file, just like in task 3. And sudo chmod 4755 valve command, it will set this permission of valve executable file so that the user, you, which also the owner, can read, can write, and can execute. But the group, the G, can read, cannot write, and can execute, and also all the others can read, cannot write, and can execute. And this sudo syscontrol wfs protected symlink, this command is to enable built-in protection against race condition attacks. So this is the command that need to be inserted into the program so that the built-in protection against race condition attacks will be enabled. So just like this in step 3 in task 3, the both bash script file here grant the owner the U to have execute permission by changing mode of the file and add the permission with the command that we can see here, chmod u+6 victim sh, and also to the attacker. So the result of this task, as you can see here, after 20,433 times changes of the directory of the target symbolic link of temp xyz file between dummy file, the abc, and protected file /etc password, the victim here in the upper box, victim.sh bash shell script show error message, which is the segmentation fault called dumped, means that program trying to read or write an illegal memory location. So we were not able to successfully exploit race condition vulnerability when symlinks protection is enabled. So the summary of this task is that same attack is done as in task 3, but this time we failed to exploit race condition vulnerability of the system. This is due to the ID between the file owner, the root, and the symlink owner seed is mismatched. They are not the same, and it is not allowing us to follow the link and write to the targeted file that requires root privilege. However, this mechanism is not fully reliable because it has a few limitations. The mechanism works only for sticky bit directories like /temp. Therefore, the attacker can exploit the race condition in other directories and gain access. So let's move on to the task for demonstration video. So as a conclusion, we have successfully demonstrated all the tasks for race condition vulnerability lie. The limitation was determined as shown below. So firstly, it works only for directories where sticky bits are enabled. Secondly, the protection mechanism denies access only in a couple of cases, as shown as in the screenshot that we have explained previously. In the fifth case, where the follower is root, the owner of the directory is seed, and singly owner are both seed and the attack is successful. So therefore, this can be exploited and rest condition will work for a directory owned by the root. So that's all from us. Thank you for watching.